Iron flakes is pure iron. Iron will be only iron. Nothing else is there. Have you done this? Okay. So what is sulfuric acid? It is H2SO4. Sulfur dioxide. See, sulfur. Okay, dioxide. Oxygen. How much? Di. Di is 2. So SO2. Sulfur dioxide. What is carbon dioxide?
CO2.
Carbon dioxide. Did you understand? What is milk made of? I'll just put up all these things so that you should know. What is milk? So what? What is carbon monoxide?
CO2.
That's all. Mono. Mono is 1. 2 is 5. 3? 9. 9. Sulfur dioxide.
CO3.
There's nothing as CO3. CO3 is not there, but trioxide. Anywhere you have a tri thing, that is always switched to this. Like for example, phosphorus trichloride, PCl3. Okay, this is phosphorus trichloride. Okay, phosphorus pentachloride, penta, right? So it all depends upon how. Are you clear about all these things? Okay, now come on, write down the definitions. Okay. First one is about an element. What is an element? Element is a pure substance. Element is a pure substance, which cannot be broken down into simpler substances. Element is a pure substance which cannot be broken down into simpler substances. What is a simple substance? We may write another sentence. A pure substance or an element. A pure substance or an element. Write another simpler substances. Write another sentence. Pure substance consists of a single type of particle. Type of TYPE, type of particle. Okay. Examples, of course, we have already given in the chart. Is mercury an example? Is a mixture or is it a compound? It's an element. It's an element. Mercury consists only of mercury, not many elements. Okay. So that is an example of an element. Okay. Next one. Leave a line and write down. What is a compound? A definition of a compound. Compound has two or more what?
Elements.
Element, use the word element, two or more elements in a fixed ratio. Or you can write as a fixed composition.
Ma'am, in compounds, if you like take away like H2, it's basically H plus O.
Right, you're right.
But if you take H2 and plus O, which is completely like different, it will make another. It will basically
So
make
basically what you are telling is you can suppose this is water. Okay. So you have got H2 and O. It is possible to break up this particular molecule of water by certain chemical processes. Like for example, electrolysis. Electrolysis is your constant current through water, and it is possible to split it into hydrogen and oxygen. Okay, it is possible, but not all substances. For example, if you are talking about, let us say, substances like carbohydrates, which you have digested, carbohydrates you are consuming, isn't it? From a moment,
Even breaking down by the hydrochloric acid. They're also breaking down by dialysis.
yes, basically we are breaking it down into smaller molecules. Okay, so when you are talking about a compound itself, it is made up of different types of substances. Okay, and what are these substances? These are all nothing but the basic elements. Okay, come on, take up. Okay, you written that? And it is in a fixed ratio. Okay, come on, write down. It can be broken down into elements. It can be broken down into elements by chemical or electrochemical processes. Electrochemical processes. That means there are certain special methods by which you can break down a compound. Correct? Okay. Have you written one or two examples? I've written so many examples, right? All those words I just give you some examples. Last one we'll talk about mixtures. A mixture contains more than one substance. A mixture contains more than one substance. It could be elements and compounds.
More than
One substance. In bracket, you can write it is either element or compound. It can be element or compound.
So now what is the difference between a compound and a mixture?
What did we say about a compound? It's a fixed proportion. Whereas in a mixture, it can be any proportion. Okay. What about example of mixture? I'm going to give you as soil. What is soil made of?
Humus, then plants.
Itself is humus, no? Humus is nothing but very decaying matter. What else? Does it have minerals? Does it have elements? Yeah. Okay, and the soil in different types. Alluvial soil is different, you've got black soil is different, sandy soil is different. Different type. So it has got very mixture. So soil is another example of a mixture. Do you understand what is the difference between a mixture and a compound? It has got various substances and you can represent in every proportion. Is that okay? If you look at your textbook.
my mixture, example of mixtures could be anything like
So many. See this table on the last page of yeah, correct. So we have identified what are mixtures, we have identified what are compounds. Did you see that? See the first point of mixture. Element or compound just mixed together form a mixture. And no new substances form. Okay. Look at compound. Elements react to form new mixtures. To form a new compound. Okay. There's a reaction which is taking place. Second point is it has got variable composition. Composition is not fixed here. It could be anything. Like for example, we have discussed about milk. Okay. Composition is fixed. The composition of a new substance is always fixed. We have seen that the composition and the ratio of the various elements which is present is always going to be fixed. Third one is it shows the property of the constituent substances. Okay, the same. I'm giving you one more example. Let's say because it's very hot, I want to make some, let us say, lemon juice. What are we put?
Lemon, sugar,
Lemon,
water, ice,
water,
water.
salt.
He says he wants to have salt also. Okay, very good. Now can you identify what is lemon juice?
Sure.
and a compound?
Mixture.
Sure.
Mixture.
Mixture, sure. I can take 1 glass of water, or I can take even half glass of water. Lemon, half of lemon, I can take 1 spoon. Sugar, I want to put 2 spoons, you put 1 spoon, 2 spoon. I want to put salt, I don't want to put salt, I can make it. So definitely, lemon juice is a mixture. Yes, because it has got varying composition. But am I making any new substance by putting all these things? No. And I can make out that it has got this, sour and sweet taste. So obviously, the components that is going into the lemon juice is still able. We can see the third point. Mixture shows the properties of the constituent substances. Constituent substance. That means whatever we are putting, it still contains the same. Okay, compound. What is it? What does it tell us? Third point. Let us see whether this is correct or not. See here. Water. It's made up of 2 substances. What are the 2 substances? I've got hydrogen, I've got oxygen. Hydrogen is a gas. Is this a gas? What about oxygen? Yes. So properties are entirely different. Does this catch fire?
No.
Hydrogen
Yes.
is inflammable.
I mean, oxygen is.
It's not inflammable, it supports combustion.
Support.
If there is no oxygen, it will not burn. So it supports combustion. What about water?
It.
I mean,
Puts out. It puts out light.
it can be a good conductor of fire.
Conductor, no. I'm not talking about that. Conductor can water conduct fire. If fire is there, you put water on it so that it is
Water is
extinguished.
Mineral water.
What is mineral water? Where are you getting this? Tell me. Conducts electricity. That is what you're saying. Conducting electricity is different from fire. Fire is actually flame. So we are taking water to put out the fire. Okay. So properties of a compound is very much different as when compared to the properties of the constituent elements. Look at third point. Third point. New substance has got totally different properties. Is that okay? And the last point is constituents can be separated fairly easily by physical means. Here we have to use either a chemical or an electrochemical. Okay. Suppose I say I'm giving you iron filings. Okay. And I say there is sand. Is it a mixture? I'm taking your dish and putting some iron filings and putting sand. It's a mixture. Now I'm asking you, how will you separate it? Very simple. Yeah, I don't know this. What force?
Electrostatic force.
Electrostatic force. Magnet. Yeah, correct. Correct. You just have to use a magnet. Take this as a magnet, you run it through. What is sticking onto this magnet? Iron pieces. So you can use simple methods to separate. Okay, I must put a tick mark now. Table. What is the table? Point two?
Yes.
Put a tick mark. That is for homework. I want you to write it down. Take down your homework. Okay, table 2.2. Table I want you to write. No, I don't want you to write now. This is for homework. I'm giving you a few things for homework so that you remember and you revise it once again.
I will write it now.
Sorry, that has to be done. Homework has to be done.
I might just come like at 4 o'clock from school and
All of us are. Unless we are at home. I'm not saying right now. Over the weekend, you can do Saturday, Sunday, you can do. Your class is coming up only on the next Wednesday. You have time. Okay, come on now. Come back to the page where we are starting.
mixtures have different elements to it.
It can be, yes, yes. I'm coming. That's what I said. We are going to talk a lot about metals, metallites, all these are elements. Element will be metal, non-metal, and metallites. Mixture is we talk about alloys.
I mean, elements, metalloids are also a kind of mixture, right?
Metalloid has properties of both metal
Both of
and
metal and
metal. It is an element. It is an element. See the first page. Did you understand what is a mixture? We have already seen. See this
Types of
paragraph?
mixture.
Did you see this paragraph? You read? Read.
Have you ever noticed the word
Read from here, somewhere here now. Somewhere in the fourth or the fifth one, yeah.
when
Where
a scientist says that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. A pure substance consists of a single type of particle.
underline that it consists of a single type of particle. Now, all of you should be alert. Huh? These are some of the words I have stressed. We have written down the definitions of them.
In other words, the substance is a pure single form of matter.
Yes. Underline that part also. Okay. Got it?
As we look around, we can see that most of the matter around us exists as mixtures of two or more pure components. For example, seawater, minerals, soil, etc. are all mixtures.
So you have got more examples of mixture, at least what we have already discussed. Soil, different types, seawater, okay. Obviously, all of them are mixtures. Okay, come on now. What is a mixture?
What is a mixture? Mixtures are constituted by more than one kind of pure form of matter. We know that dissolved sodium chloride can be separated from water by the physical process of evaporation. However, sodium chloride is itself a pure substance and cannot be separated by physical process into its chemical constituents. Similarly, sugar is a substance which contains only one kind of pure matter and its composition is the same throughout. Soft drinks and soil are not single pure substance. Whatever the sources of a pure substance may be, it will always have the same characteristics properties. Therefore, we can say that a mixture contains more than one pure substance.
Underline. Mixture contains more than
One
one
difference, differentiate between elements, like on different categories.
elements. When you are talking about element, we said element can be metals, non-metals, and metalloids. Okay, oxygen is a non-metal, fluorine is a non-metal. Okay.
So, or like gases, just like take gases as an example. Can you differentiate between like them as the categories?
That's exactly what I'm saying. Most of the gases obviously are all non-metals. Okay, like for example, if you're talking about calcium, aluminum, zinc, platinum, all of them are metals. And there are some of the elements which have got properties of both non-metals and metals, and they're called as metalloids. Okay, so metalloids, metals, all of them are elements. Did you get it? Okay. Now here they have given you example of, let us say, salt water. How will we make salt water?
Salt and water.
Exactly. So you are taking water and you are adding salt. What is salt? Na.
Na2.
You don't know salt?
NaCl.
NaCl. NaCl is salt which is called sodium chloride, isn't it? What is this? Sodium. What is this? Chloride. If I take only Na, is it an element or a compound? It is an element. Chloride, chlorine is also an element. But when these two combine together, what does it form? It forms a compound. Is it in a fixed proportion? Yes. How many atoms of sodium we have taken?
1.
Chlorine also we have taken 1. So 1:1. We have taken 1 and 1. The ratio is 1:1. Sodium chloride itself is a compound. Correct? What is it made of? It is made up of 2 different elements. Now, can I make salt water? Is it a compound or a mixture? Yes. You understand? I can take 1 glass and I can put half a spoon. I can take 1 liter and I can put half a spoon.
But then the quantity is still.
What is the problem? What did we say about mixture? Mixture may contain 2 or more different substances.
But you also said that it is physically removable. How will you
Okay, suppose I have got salt water. Can I separate the water and salt?
Just heat the water up.
So
Evaporation.
Yes, suppose I take beaker which contains, let us say, salt water. This contains water and it also contains salt. What will I do? I'm going to heat it up, yes. So you heat it up. What comes out?
What is that?
Evaporation. Yes. Okay. So basically, you are evaporating water. Yes. So it is easy to separate out substances by certain simple physical processes. You have seen them. God has given us a backbone. Backbone, we are having backbone. Substance of that. Okay, right? Is that okay now? All confusion, there's no more confusion. Okay, so that is your. Now here, yeah, we have finished. So we have identified 3 different types of substances: elements, mixtures, and water compounds. Okay? And we have understood by using different type of examples. Now, today we are going to do a lot more, I said, about mixtures itself. Okay, we are going to identify what are the different types of mixtures that could be present around.
Types of
I have given you one simple example. Let's say I have got salt water. Okay. So what did we do? I have taken a beaker or I have taken a test tube or whatever it is. I have taken water and also, of course, I have put some salt. I am going to stir it by using whatever it is. I am going to stir it. Okay. I am going to stir it. After this, can you make out which is salt and which is water? No. Everything has already dissolved. Correct? So such type of substance which is formed is a solution.
Ma'am, that's what I was talking about when I was when it's
Okay.
dissolved.
Salt solution.
It is a salt solution or it is a sugar solution. What are the 2 things that we have put here?
Salt and water.
You have taken water and you have taken salt. Okay, it is a solution. So salt is dissolving in water. So this is a solvent. What is water here? What is here? Solvent.
And the solution.
And this is your solute. So what does a solution consist of?
A solute.
A solute and a solvent. Got it? Which is more, which is less?
More is the solvent, less is the solution.
Solvent is more, and this is. Suppose I say sugar solution.
Sugar and H2O, where sugar is the solute and water.
Solvent will be water. So solvent is more and solute. Yes.
Sugar and glucose they are different.
Sugar basically is a disaccharide. Glucose is a monosaccharide. It's a basic molecule, is nothing but glucose.
But then by then glucose is
But what I say
C6SO6
is glucose.
and then why glucose is called as complex sugars.
Yeah, the complex sugars because monosaccharide is a single unit. Disaccharide is 2, di 2. So it's a disaccharide. So this. What is starch? It is a polysaccharide. Poly means many. So you have got many glucose molecules in this. It's when it becomes a polysaccharide. Is that okay now? Okay. So we have identified that a solution will contain a solvent and a solute. Solvent is always more. Here, of course, we have taken one liquid. One is water, and the other one is a solid. So many more substances are present where it need not necessarily be a solid and a liquid. For example, I can say air is a mixture. Is air a mixture?
Oxygen and some gases.
Yeah,
Carbon
definitely.
dioxide, argon, and
Air is definitely a mixture. Major portion of it is what?
nitrogen.
How much is it?
78%.
Exactly, 78% of air is nitrogen. 21% is what?
Oxygen.
So how much does it total to?
99%.
Okay, so approximately 1 more percent it consists of many more gases. Argon, carbon dioxide, so many other gases which all comprises together of another. Okay, did you see? So it is a mixture, but all of them are in a gaseous state. So a mixture can be in a solid state and a liquid state, and all of them can also be okay. Now somebody was mentioning about alloy. What is an alloy? Have you
Mixture
heard
of
of
two
an alloy?
metals.
Mixture of
Two metals.
Like rock.
bronze, correct? Okay. It is a molten. So you are taking copper, you are melting it, and of course you are taking either tin or zinc or whatever it is, stainless steel. You are taking iron as a base material. So alloy is nothing but a homogeneous mixture. So such a type of a substance is what is known as homogeneous.
Alloy is not a pure substance.
It's not a pure substance. You are taking a base metal like copper, okay, brass or bronze or whatever it is. That is how you are making it. So alloy is also
When I say there's a definition, it says they have the same composition properties.
property. Yes, you can easily make out that it still contains. Like for example, air is a mixture. Oxygen will have its own properties. Oxygen we are taking in, isn't it? It has its own properties. Correct? Hydrogen has its own properties. It does not form a new substance. Correct? But only thing is it is homogeneous because you can't separate it into two different. You can't say this is copper and this is zinc or whatever. Now let me give you another example. Okay, so since we are talking already about mixtures, we are identifying another type. Similarly, I am taking a beaker, I am taking water, but now I am putting sand. What will happen?
And actually,
Is it a mixture? Is it a mixture or a compound? Is this a mixture or a compound? It's a mixture. Isn't it a mixture? You can take 10 ml of water, you can take 100 ml of water. It is sand and water. But now, after some time, what happens? Can you make out which is sand and which is water? Because it will settle down. After some time, you will find that all the sandy particles have settled down. So even though it is a mixture, what type of a mixture is it? It is a heterogeneous mixture. Heterogeneous mixture. Okay, so I'm now talking anything more regarding mixtures, and we have identified mixtures in the form of either homogeneous or heterogeneous. Heterogeneous mixture is where you can actually make out two separate things. For example, if I'm taking a test tube, okay, and I'm putting oil and I'm putting water.
Oil will settle down and it is heavier.
Or is it the other way around? But can you make out that there are two separate layers?
Oil has formed a layer over the water.
So you will have a layer, you will also have another layer. Okay? It depends upon the density of the two different substances that you have in there. So you can make out whether it is a heterogeneous mixture or it is a homogeneous mixture. Yeah, come on, right now. Once again, from whatever notes that we have given you here. Okay. So write down a table like this, and you can also write down the points that I'm giving you here. Point number 1, 2, and you can also take out some examples. Mixtures, homogeneous or it can be heterogeneous. But if you're not comfortable with it, this you're not comfortable. Right? Take it. Homogeneous mixture, uniform composition. You can take mark. I'm talking about this here. Uniform composition. Heterogeneous mixture. These are these. 1 year. And write down the examples. So many examples, at least, yeah, two examples at least for each one of them to write. Sugar in water, salt in water, sulfur in carbon disulfide, water and etc.
Carbon dioxide.
They have sulfur in carbon dioxide. Sugar water, salt water, that is solution. There is also a solution. Okay. Heterogeneous, write down some examples. Are you feeling better? No. Doesn't look like. What about human blood?
I'm homogeneous.
What is it made of?
Cells
RBC, right? What else? WBC, RBC, WBC. And because it is in a flowing medium, water, it is nothing but plasma which is present. So by these things, if you just look at it, you will not feel as if it is homogeneous because these particles can be easily separated.
How can the RBC separated? RBC can be
Centrifuge. Suppose you go to the hospital and a patient needs only RBCs, okay, they can fight, you can get it from a blood bank. Suppose a person has got a lot of blood loss due to some accident and he requires, it is a plasma, you can get it from a blood bank. Okay, so that is an example. We are going to read about that particular technique also. As far as the centrifuge, by using that centrifuge, you can actually separate out the components. Yes.
Means like every fluid liquid is
Alcohol, for example. Alcohol does not have water. Okay, doesn't have alcohol. Okay, for example, petrol, kerosene, diesel, they're all liquids, but it does not have water.
So all those.
For example, milk acid definitely has water, blood will definitely have water. Then we come back to this screen again, types of mixtures. Come on here. Here. Kaushik, you have your text with you. That is on your page number 14. Come back to page 14. Yeah, yeah. Yes, types of mixtures.
depending upon the nature of the components that form a mixture, we can have different types of mixture. Dissolved in water. Compare the color of the solution of the two groups. Though both the groups have
No, that is a definition of activity. There's an activity 2.1 and 2.2 that I will explain afterwards. Okay? Regarding activity. So what we have said is types of mixtures, we can have different types of mixtures. Then there's something you can learn about solutions from once again the house. What are solutions? Read that.
A solution is a homogeneous mixture of two or more substances.
Underline what is the solution?
You come across various types of solution in your daily life. Lemonade, soda, water, etc. All are examples of
What happens in soda water?
Carbon.
We are taking water. Sugar of course is already there and they are bubbled in what? Carbon dioxide. So this is an example of gas which is present in a liquid. Got it?
all are examples of solution. Usually we think of a solution as a liquid that contains either a solid, liquid or a gas dissolved in it. But we can also have a solid solution.
No, you're right. That's right, but we can also have a solid solution which is a halide. Halide. Okay?
And
Halide is what?
solutions
It's a homogeneous.
in a solution there is homogeneity.
What is homogeneity? It's homogeneous at a particle level. That means you cannot make out something from it.
Homogeneity at the particle level. For example, lemonade tastes the same throughout. This shows that the particles of sugar and salt are evenly distributed in the solution. Alloy. Alloys are mixtures of two or more metals or a metal, two or more metals or a metal and a non-metal, and cannot be separated into their components by physical material. But still, an alloy is considered as a mixture because it shows the properties of its constituents and can have variable compositions. For example, brass is a mixture of approximately 40% of zinc and 70% of copper.
Okay, so what is alloy here? It is a mixture of two metals. Two metals, okay, both of them are present in a molten form. For example, they have given you brass, so copper and zinc. 70% is copper, molten copper, and you have a 30%. Stainless steel. What is the base material?
Steel.
Steel is a mixture. What is it made of? It's an alloy. Iron, you take iron, okay, you melt it, and then you can put carbon, you can put chrome steel, you can have, chromium, you can put manganese is also called. Okay, so depending upon the type of steel that you want, you can put different type of elements. Is that okay? Now,
A solution
that is important. Look at the next paragraph, underline. Solution has a solvent and a solute. A component of solution that dissolves other component, which is usually present in a larger amount, is what is known as a solvent. So I want you to distinguish between what is a solvent and what is a solute. Okay? The component of the solution that is dissolved in the solvent is what is known as a solvent. Is that okay? Come on, write that down. In your notebook, come on quickly. Have you taken down this? Write it down. Solution consists of a solvent and a solute. Here, of course, I have taken example of salt and water. Just write down solvent and solute. What is a solvent? Write down what is a solvent, write down. And what is a solute, write down.
Ma'am, I'm writing the whole paragraph.
As two separate points, I want you to write it down as two separate points. What is a solvent and what is a solute? Right? For your homework, what did I ask you to do?
The table.
Yes. And I want you to read up this activity 2.1 and 2.2. All of you remember? Read activity 2.1 and 2.2 because we are going to discuss about this. You understood now?
Yeah.
Or this one and this one. Read and come. I'll ask you. Okay? Thank you, class. We don't stand. We do that now. Thank you. Easy.
लीव करो
आज तो आता सांगायचं ना
मॅम ने सांगितलं मॅम बोल
मैडम विसरतात सर क्या मैम को पता नहीं क्या लाइव करने के लिए
बोला हमने मैम ने बोला बताया कब बाद में बोला
स्टीम करने के लिए
आई अरे मैम ने बोला हैंडल दूर आप लोग
आधे घंटे तक स्टीम नहीं होता 15-20 मिनट
बहुत